Hello, good evening, everyone. Uh, Today is 15th May. Our time is exactly 6:10 p.m. So, good evening, everyone. And we are going to make a video on first chapter, that relation. 12th class, first chapter relation. A quick revision type class. A quick revision type of video so that you can go through, and in the limited time slot you can revise all the things, all the concept of the relation that it consists actually. So first of all, I want to show you the flow of concepts, sorry. How can you relate the relation before starting with the another concept of the set theory? So before starting the relation chapter, we must have know about the ordered pair. What is ordered pair? Then after ordered pair, we must have a information regarding Cartesian product. And if you know Cartesian product, then we are in the position of defining a term relation. And after that relation, we know the function. For the function, I have to make another video. So our today's video class is restricted to the relation only. So what is ordered pair? So ordered pair is two elements enclosed within parenthesis. Two elements enclosed within parenthesis A comma B. And as the name suggests, we are saying order means ordering is important. So A comma B is not equal to B comma A. Okay. Now Cartesian product. Cartesian product means we have a two set and we want to find the product of set A into product of set B. So it's basically product of two set of set theory. Okay. So Cartesian product basically defined as A cross B. And A cross B, it is A comma B such that A belongs to the first set and the B belongs to the second set, where A and B are the two non-empty set. So this is actually Cartesian product what it has. Now relation. Everybody is in relation. Everybody, all the society people are belongs to the relation. So if I have my father, my mother, then the sister, brother. So we are in a relation to each other, brother relation, sister relation, whatever. But I cannot say something outside who is roaming on the road that he is my brother, he is my sister. So they actually belongs to. So they actually belongs to the out of my family. They are not from the blood relation. Similarly, a relation is a condition, a rule imposed on A cross B, the two set A and B, and you can choose a pair from A cross B. Okay, but that pair must satisfy the given rule or regulation, whatever it is defined in relation. So that relation must be a subset of A cross B. You cannot think about outside the subset of A cross B. No, this is not possible at all. That relation must be ordered pair element, and that ordered pair element must be a part of A cross B. Sometimes it's also called R is a subset of A cross A, and if the things are repeated, then it is also called binary relation. So I hope you guys understood. If the sets are given, for making the pair, we must have to find the Cartesian product of those two sets. And after finding the pair of those two sets, we have to search for the pair that best suits that rule that is given in the R. And here also I also want to make it clear that every time in the question relation is given, what we have to do, we have to verify whether that relation is corrected, defined or not defined. Okay, so relation R must be a subset of A cross B. Now, if you go through the relation, two basically relations exist that has no existence in terms of the question, but you must know Like if R is equal to complete Cartesian product A cross B, then in this case we can say that the R is an inversion relation or trivial relation. And if R is equal to completely phi, empty set, like if I say let R is defined on the set A is equal to 1, 2, 3, and if I am asking that ki A comma B such that A minus B greater than 20, A greater than 20, is it possible? What I am saying that A is equal to 1, 2, 3, R is a subset of A cross A, and I am taking A as A cross B such that A minus B greater than 20. So 1, 1, 2, 2, 3, 3 or any pair of A cross A not have difference greater than 20. So in this case, the value of R is equal to phi. So we can say that the R is an empty relation. Okay, I think you guys understood. Now, what is identity relation? What is identity relation? So, identity relation means an element relates itself like A comma A such that A belongs to A. But it differs from the reflexive relation. How? Because in the identity relation, only the element given in the set is present. Like if I say if A is equal to 1 comma 2 comma 3, so what is IA contains 1 1 2 2 3 3. Now this only, because it has three elements, so both all the three elements, one is 1 1 4 2 2 2 3 3 3. No other pair is going to present here in the identity relation. But in the reflexive relation, apart from identity relation, other pair is also present. That is the difference between identity relation and reflexive relation. Okay. Now come to this side. Come to this side. Types of relation. So if you observe, there are two types of the question given in the relation. One is for the single set. One is for the single set and another is for the paired set. Like set A is there, set B is there. From set A small a is coming. From the set B, a small b is coming. And then A and B forming the pair called A comma B. So this is relation defined for the single set. So for that type of set, what is the definition of reflexive relation? It is also called itself relation. Itself relation means an element relate itself, like A comma, if A comma A, the signature step. What is the signature step of this definition of reflexive? If A comma A belongs to R, for every A belongs to A, then R is reflexive. This is the for the single set. What about symmetric? What is the signature step for the symmetric relation for the single set? It is if AB belongs to R, then BA belongs to O. There is a wide meaning of if. If I am something, then I can do something. First condition is there, then second condition is there. If first condition is negligible, not present, so itself relation becomes symmetric. No argument at all. So if AB belongs to R, then opposite pair must be there in the relation. That's what it is written here. And transitive, if AB and BC belongs to R, then AC belongs to R. So see, this is called transitive pair. It ends in B and start with B. First pair ends in B and the second pair start with B. So this is called transitive pair. And if two pairs are there, then we are thinking about the third pair. Otherwise not. Okay, so this is the definition for the single set. What about for the paired set? For the paired set, the definition is if AB related to AB, one pair is related to itself, then it's called reflexive relation. What about symmetric? If AB related to CD, then CD related to AB. Again, opposite thing is there, but in terms of pair, not in terms of element. So if AB related to CD, then CD related to AB, then R is a symmetric relation. And what about transitive? Two pair we have to suppose to be assume here. If AB related to CD, CD related to EF, then AB related to EF. So if this happens, then the relation is transitive. And if for any relation, all the that relation is reflexive also, symmetric also, transitive also, then that relation is called equivalence relation. And based upon that concept, equivalence relation, there is a term known as equivalence class. Equivalence class. For finding the equivalence class, the given relation must be equivalence relation. That is first condition. And what is equivalence class? Equivalence class of A is, we must find a second element belongs to the set, so that that pair must be in relation. That is, definition is, if B belongs to A, then AB belongs to R. Okay, so that's all about today's class. Thank you everyone. I hope you guys revise the things of relation. Thank you.